Hey, what's up guys, Jeremy here. It's now time to talk about speed and rounding within the Curve Photo project. Let's get started. Now that we know how to select the curve, manage the orientation, manage the approach and retract motion, and manage the pram events, let's see how we can manage the speed of operation and the speed of the approach and retract motion. So obviously the speed of operation is relatively simple. You have here in your Curve Photo project a section called operation speed, millimeters per second, and you can enter a value. If you go to your Curve Photo project here and the program that was generated automatically, you can right click and select show instruction. Here you will see that you have a few set speeds that were automatically set by the robot, by the software in fact. So here we have 3 set speed. So the operation speed will always appear right at the beginning of your program. So if you go here, first motion to your approach, second motion, then here, by the way, you have some motion that repeats themselves. That's normal. And don't worry, they won't be repeated in the program you will generate to the real robot. There's kind of a filter when you generate program before it's kind of sent to the post-processor that will eliminate any duplicated motion, so that's not a big deal. And then here you have your gun on that was generated because of the pram event we saw in the last video. Another move to the same position, like I said, don't worry about that. And then you have your set speed 50 millimeters per second. If you right click edit, it will have here set speed in millimeters per second, and then you have your 50 millimeters per second that you set here. So if I was to delete that here, enter 100, update, right click, show instruction, we now have set speed 100 millimeters per second. Great. For the approach and retract motion, it's a bit different. As you can see here, if I go here, we have a fast motion at 1000 millimeters per second. Then we have our operation speed at 100, and then towards the end, another 1000 millimeters per second. That's kind of a big difference. So if I were you, I would go to pram event. And then here you have your fast move speed. By default, it's 1000 millimeters per second, but you can lower it down, let's say, to 100 millimeters per second. So this will affect this section here, this section here, this section here, and this section here. If I delete here, update, simulate, like that here. Perfect. So now it was at 100. One thing that I really want to mention though is that this won't affect the first movement to go there, because the first movement to go there is a joint motion, and the joint motion isn't affected by this set speed in millimeters per second. It needs to be affected by set speed in degrees per second for the joint motion. So what I would recommend you is, if you want to change that, if you're fine with the default value the post-processor will give you if you're generating the program, you can always just leave it as is, or you can click on set speed here, and then you can enter another value, let's say 180 degrees per second. Click OK. If you don't understand well how set speed works, I believe in module 7, I have a video specifically on that topic. So you should take a look. I'm explaining more in details how speed works. Now I'm concentrating just on how speed works within RoboDK. So if I do that here, now we'll have 180 degrees per second to go reach that point here. And then I will have the rest of the program run at 100 millimeters per second for all of those sections. So that's cool. Now let's talk about rounding. So if you go here, if you look at your program here, you see you have smooth 1. If you go to pram event, you have set rounding millimeters or percentage, and then 1. What does that mean exactly? So rounding has many names in robotics. So let's say for cobots, oftentimes they call it blending, continuous motion for certain industrial robot brands, or zone data, or yeah, I can't remember other words, but like there's, I think, 4 or 5 terms to define that specific concept. The concept is to have like fluid motion. So by default, if you don't set anything in robotics, the robot will stop at each point that you're asking it to go. So it will stop at the first point, the second point, third point, and so on and so forth. Most of the time, especially when you were doing param like these, that kind of have a lot of points, but we want it to be fluid. If you want to dispense the fluid in this case properly, or if we want to machine or cut and stuff like that, we don't want to stop at each point. That wouldn't make sense. Especially here, it would be like bad, as we would create like some pile of material, if I can say. So by default, you have a smooth of 1. So a smooth of 1 or a rounding of 1 will mean different things depending on the robot you're using, but it will at least try to be fluid. So if you're a robot, when you're exporting the program, if you right click and generate the robot program, if you feel like your robot is kind of still stopping at each point or is not very fluid, I would recommend you to come here and kind of increase that value. So you need to have some kind of understanding of how your robot works. In this case, some robots will require you to have a percentage, so you enter it as a percentage. Some will require you to have a value in millimeters, so consider it as in millimeters. Within RoboDK, as soon as you have 1 or more, it will be considered as smooth, and you won't have any slowdown between the points. But that might be different on your robot, so you might need to increase that value on your robot. So if I go back to param event here, and I can change the value here. So let's say I can go and add 10 here. So if I do that, delete this one here, update, right click, show instruction, and now I have 10 here. I could modify it directly here if I want. Also, when it's done, I can just enter whatever value I want here. If I want to make sure that the robot will stop at each point, let's say that I need it to stop at each point, what I can do is go to param event and I can enter -1. If I do that and click OK, update, right click, show instruction, I will now have dimension accurate. Edit -1. So -1 will make it accurate. So if I run that like that here, it will go to each point, and as you can see here, it's not super fluid. It's like tuk 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 tuk. This is because I'm stopping at each and every point, and I have to kind of reaccelerate. So if you were to look at the velocity curve, it will be like 0 linear top speed, 0 linear top speed, 0, and so on and so forth. Okay, that's pretty much everything for this video. I hope it was helpful. In the next one, we will discuss the optimization parameter here. So how RoboDK helps you avoid singularities, joint limits, reach limits, and other traps you will have in robotics when you're trying to follow complex curve. So that's another very important video. I know what I'm saying that all the time, but this module as a whole, as I said in the first presentation or introduction, is potentially the most important module if you're trying to follow advanced paths. So don't skip any of those. So yeah, we'll talk about how the optimization parameter works and how it can help you and sometimes not help you in certain situations. So how to avoid the traps related to the optimization parameters. In any case, I hope to see you there and have a great day.